In this video, we're going to solve equations with exponentials. Let's first take a look at number 25. That one looks good. Now, as I look at 25, I do notice that I have a base of 9, a base of 3, a base of 27. Now, to solve this a little bit easier, I probably want to make them the same base. That's what's going to make these problems a lot easier. So 9 is the same as 3 squared, and then that's to the power of x. 3 to the power of 3, and 27 can be thought of as 3 to the power of 3, and then that's to the fourth power. Now, based on our laws of exponents, we also know that if you have parentheses, it's like multiplying them together. So 2x, and then here we have 3 to the third, and here we have 3 to the 12th. We also notice that we have same bases here, and when you have same bases, you can actually add those exponents up together. So we have 3 to the 2x is equal to 3 to the 3 plus 12, or 3 to the 15. Oh, look, same base. Look at that. We've simplified it down, so that must mean that exponents must be equal to. So we're saying 2x is equal to 15. Or in this case, x is 15 over 2, like that. All right. So that's the main gist behind these problems. The idea here is try to get the bases to all look the same. Let's take a look now at number 27. Let's see if we can get these bases to be the same. Notice how they all have a common base of, hopefully what you're saying is 3. There are a couple exponent properties that we need to put into play though. I do notice that this is x to the power of 2, right? 3 to the power of x to the power of 2. That's the same thing as, let's see, this is 3x squared over, now if you have to the power of a power, that's the same thing as multiplying them together. So you have 3 to the power of 2x equals 27. That's the same as 3 to the power of 3. The idea here is let's get a common base of 3. And once we get a common base of 3, we can start combining them together. If they have the same base, you're dividing those exponents, you can actually subtract those powers. So what do we get? We have 3 to the power of x squared minus 2x equals 3 to the power of 3. Again, same base, meaning that if the bases are the same, then so are the exponents. So that means that x squared minus 2x is equal to 3. Oh, that looks like a quadratic. We can solve that. Now remember, if you want to solve a quadratic, you do need to get the zero product property. So we need to subtract the 3. Make sure you show that you get the zero product property so you can actually factor your quadratic. Okay, so in doing so, this is factorable. Yeah, that looks factorable. That's what, x minus 3 times x plus 1 equals 0. So therefore, x is 3 and x is negative 1. There we go. Okay. All right. Let's take a look at the next page. All right, number 29. Let's take a look at that. Now, number 29, I did want to give you a kind of a premise to how we should be looking at these problems. So I am giving you something not quite with exponentials that you're going to be working with. It's just more on the easier side here. But the idea here is that if I did ask you to factor this problem, hopefully what you would say is what you're looking for is finding the greatest common factor. And in that case, the greatest common factor would be the x to the third power, and then what you're left with is 5x plus 2. Okay? Now, what exactly did we do, though, when we found the greatest common factor? Well, finding the greatest common factor technically means what you're looking for is the exponent with the smallest number. Exponent with the smallest number. Okay, and then when you took out that exponent with the smallest number, what you were basically doing was taking all the exponents and subtracting it by that number. So that 4 got subtracted by 3. The x to the third also got subtracted by 3. That's why it's not there anymore. 3 minus 3 will give you 0. Okay? Everything else that you didn't factor still remains inside parentheses. That is the rule that I would like for you to think about as you factor our next case. Now notice how it's a little bit more complicated, but you use the same rule. You ask yourself, what do each of these two terms have in common? What is this greatest common factor? Remember that the greatest common factor is actually looking for the smallest exponent. In this case, which exponent is smaller? Half or negative half? Hopefully what you're saying to yourself is the negative half is smaller. So that's what we're going to take out. We're going to say x minus 1, oops, that parentheses is too big, x minus 1 to the power of negative half is what gets factored out. Now what happens though? Well, we take this half here, and now we have to subtract it by that negative half, right? We're taking that negative half out of it. Well, what's half minus a negative half? That's going to give us an exponent of half minus negative half is like saying half plus half, or that's the same thing as x minus 1 to the power of 1. And then from the second term, if we take out the entire x minus half to the negative half, then again, you're like saying let's minus a negative half, or that's the same thing as adding half. What's negative half plus half? That cancels out. That's why this goes away. And what you're left with then is, what's left over? Minus x, like that. Okay. Now, let's simplify a little bit more. We have the x minus 1 to the negative half out there. And then if we simplify what's left in parentheses, x minus 1 to the 1, I mean, that's really just x minus 1, minus x. And then the x minus x cancel out. So, it looks like we're only left with negative 1 here. So this turns into negative times x minus 1 to the negative half, like that. Okay. All right, let's do another one. This time, we're going to be solving these equations. Let's look at number 31 here. Actually, I'm going to backtrack. To do number 31, I'd like to bring us over to page 3 here, okay, number 10. So I brought us back 2 pages. In this problem, we're solving 2 to the power of x plus 8 times 2 to the negative x equals 9. All right, now as we think about this, let's use our law of exponents. If we ever see a negative exponent, remember what that means. That's technically the same as 8 times 1 over 2 to the x equals 9. Let's rewrite that. That's the same thing as 8 over 2 to the x. Oh, that makes things difficult. We don't want to solve an x when it's on the denominator. So how can you get rid of something that has a fraction? Hopefully what you're thinking is whenever you've wanted to get rid of fractions with equations before, you could technically multiply the entire thing by its actual denominator. In doing that, 2 to the x is on top, 2 to the x is on bottom, they're going to cancel out. And so you will no longer have that fraction in play. Okay? But remember, whatever you multiply on the left side, you must also multiply on the right side. You gotta have an equally balanced equation. Now let's simplify this. What do we have? 2 to the power of x times 2 to the power of x. That means we have 2 of them. It's like saying 2 to the power of x squared plus 2 to the power of x times 8 over 2 to the power of x. Well, the whole point behind this was so that it can cancel out with this denominator here. So all we're left with then is just 8 equals 9 times 2 to the power of x. This still doesn't look any easier, at least not with the 2 to the power of x. I wonder if things got easier if I could actually rewrite that 2 to the power of x. Let's say that 2 to the power of x is actually an a value. Let's see what happens then. Then what I have, actually a, I'm now thinking looks kind of like my 9. I'm going to change that into let's change it into a y. Okay, so I'm going to make, anytime I ever see 2 to the power of x, I'm going to change it to a y. That's y squared plus 8 equals 9 times y. Ooh, that looks like a quadratic to me. How do we solve quadratics? Well, we bring it all over to one side. so we can get the zero product property. Right? We want a 0 on one side, so that way we can actually factor our quadratic, because we know that multiplying by 0 will always give us 0. So if we factor, this is the same thing as, let's see here, that's y minus 8, and we also have y minus 1 equals 0. Okay, and now remember, when the whole point behind this is so that if you factor, each of these values are like a 0. So what we're saying is y is equal to 8, and also y is equal to 1. That's what gives us the value of 0. That's why we have 0 product property. All right, well, we're not solving for y, though. Don't just leave your answer there. Remember, what we're really solving for is 2 to the power of x. So rewriting this, we have 2 to the power of x is equal to 8, and also 2 to the power of x is equal to 1. If we get them to be the same base, 8 is the same thing as 2 to the power of 3, so that must mean that x is 3. And 2 to the power of x equals 1. When does that ever happen? When does an exponential ever give you the value of 1? Ah, right there, when x is 0. Okay, so those are going to be your two answers. X is 3 and x is 0. All right, let's backtrack, or let's go forward actually. We're going to go forward 2 more pages where we left off at number 31. All right, now, the reason why I wanted to do that problem, number 10, before number 31, is because they're actually kind of similar. You can kind of see, oh, it kind of resembles a quadratic. We've got 3 terms there. The question is, how can you actually make it a quadratic? How can you make that a quadratic? Well, I'm giving you some time to think about this. Hopefully what you see is that you do have even numbers there. I wonder if we think about our properties of exponents, that x to the power of 4/3 is really x to the power of 2/3 to the power of 2, because 2 times 2 is what gives us 4. Likewise, we also have minus 10 times x to the power of 2/3 plus 9 equals 0. Now, just like we did with the previous problem, hopefully what you're seeing is that x to the power of 2/3 can be substituted with another value. Let's again call it like y. So if x to the power of 2/3 is y, what we have is y squared minus 10y plus 9 equals 0. Ooh, there's a nice quadratic. That is factorable, right? This is the same thing as y minus 9 and y minus 1 equals 0. So in this case, y is 9, and also y is 1. Remember, you're not solving for y, though. Let's change it back. Our y value is technically the same as x to the 2/3 equals 9, and x to the 2/3 equals 1. All right, so when does this happen? Well, let's solve each of them. If you have x to the power of 2/3, then one technique to getting rid of the 3, rather the over 3, is to actually take it to the 3rd power, right? So we're going to take it all to the 3rd power like that. Okay, so what we now have is x to the power of 2 is equal to 9 times 9 times 9. I'm taking it to the 3rd power. Now the reason why I'm splitting it up like that is because now the next thing I notice is that if I need to get rid of the squared, I actually need to square root it. Oh, but one thing you need to remember is that when you square root something, you also need to have a plus minus, so don't forget that part. Okay? Whenever you root something that is an even power, you always need to make sure you include plus minus. So what do we end up with now? We have x is equal to, if we take out the 9's because it's a square root, and technically 9 is 3 times 3, so we can take out another 3. That's 9 times 3. 9 times 3 is going to give us 27, and don't forget it has a plus minus. So x equals plus minus 27. 2 answers there. Okay. Actually, I think I will rewrite it so that way you are very clear that you have 2 answers, 27 and negative 27. Okay? All right. Let's take a look at our other case. X to the 2/3 is equal to 1. Well, first thing we need to do is get rid of, let's get rid of the over 3 first. So to do that, you got to take it all to the third power. Okay, so what we have now is x squared is equal to 1. 1 times 1 times 1 is 1. And then to get rid of squared, remember, you need to square root it. But at this step, when you are square rooting to solve for x, if you square root both sides, you need to make sure you include plus minus. So x is equal to plus minus the square root of 1, or that's the same thing as 1 and negative 1. So we have 2 answers again. So you have a total of 4 answers for number 31, which makes sense because you do have x to the power of 4. So you should have 4 answers. Okay. All right. Let's stop there.